algebra students, Mr. Lawrence here with your next flipped lesson. I hope you're paying attention. Hey, by the way, Mrs. Bell let me know that some of you ninth period study hall are choosing to not do work, not watch videos. You're not putting off the video to do your science homework or language arts. You're putting off the video to talk with friends and do read, books that aren't for school, just for pleasure reading. I got to tell you, I think that's a really poor choice um, for the use of your time. If it becomes a problem, of course, I'll find out who you are and I'll have to contact home. So I just want you to realize that, Mrs. Bell and I are communicating and she's giving you an opportunity to watch those videos. You definitely should take advantage of it. Now, if you're going to watch them at home and you got language arts to do, wonderful. But I know for a fact that's not what some of you are doing. You're choosing just to chill. Okay, I think that's a very poor choice. All right, enough of the lecturing. Let's talk about zero and negative exponents. Remember that we've discovered that a negative exponent means to use the reciprocal, right? For example, look here, 5 to the negative first. That's the same as 1 over 5, right? That's the reciprocal of 5. 5 to the first would equal 5. 5 to the negative first is the reciprocal. I like to say a negative exponent means I should use the stairs. A number in the upstairs, or the numerator, will move to the downstairs, the denominator. And notice the exponent on it becomes positive because it's 1 over 5. Well, how would you do a problem like 2/5 to the negative second? Well, I would do 2/5 squared. 2 squared is 4. 5 squared is 25. But then since I have a negative exponent, I would have both numbers use the stairs. I would use the reciprocal. It would be 25 over 4. Pretty easy. If I have 3/8 to the negative first power, well, I know 3/8 to the first power is just simply 3/8. Well, now the negative exponent means to use the reciprocal, or the stairs. The 8 will shoot upstairs, the 3 will go downstairs, so I will get 8/3. There we go. What would happen x to the negative first? Well, x to the first is just plain old x, right? Now I need to use the stairs. What's the reciprocal of x? Well, it's 1 over x. So it was in the numerator with a negative exponent. It ends up in the denominator with a positive exponent. All right, well, let's see how this might play out. Let's look at this problem here. We'll call it problem number 1. 20x to the negative 7th, y to the 8th, z to the 5th. Well, I see a negative exponent. Right, where'd it go? Hold on, I don't want to crayon. There we go, right here, a negative exponent. So he's going to have to use the stairs. He's going to be the reciprocal. The 20 doesn't have a negative exponent. The y to the 8th doesn't have a negative exponent. And the z to the 5th, there's no negative exponent. The only term that has a negative exponent is the x. So this is going to end up, 20 is going to stay home in the numerator. Y to the 8th is going to stay home. Z to the 5th is going to stay home. But the x to the negative 7th is going to move to the denominator and become a positive exponent. Pretty simple. How would we handle problem number 2? Well, excuse me. First thing I'm going to do is I'm going to look for my terms with negative exponents. It looks like the y term has a negative exponent. That one does anyway. And this z term has a negative exponent. So what does that mean? Well, that means that, let's see here. That means that this y to the negative third is going to shoot to the basement, while the z to the negative first is going to rise upstairs. So the problem is essentially 12 x to the 6th, z to the 4th, and then a z to the 1st over 16 x to the 8th, y to the 3rd, y squared. Now, of course, I can simplify this much further. 12/16ths, well, I'm going to divide them each by 4, right? Of course, I'm reading that way. Divide by 4 there. And 12 is going to turn into 3, and 16 is going to turn into 4. Now I have an x to the 6th in the numerator over an x to the 8th in the denominator. Well, that's going to be x squared in the denominator, right? Because there will be 6 x's in my numerator And there will be 8x's in the denominator. When they cancel, I'll be left with an x squared. All right, these z's right here will be z to the 5th power. These y's right here, y cubed times y squared, will be y to the 5th power also. And there you go. Of course, we're assuming that x and y aren't equal to 0. It's got to be a restriction, right? We're not allowed to divide by 0. That's pretty easy. In fact, it's so easy, sometimes it gives kids trouble. Let's look at problem number 3 here. Okay, I'm going to go through and identify all the terms that are going to use the stairs. This guy is going to use the stairs. So is this guy. The y's will both stay put. The z to negative third will use the stairs. So let's see now. I've got this guy going downstairs, this guy going upstairs, and this guy going downstairs. So let's see here. I can really rewrite this as 24. The x to negative 5th moved in the numerator, but its sign changes when I use the reciprocal. I've got a y to the 8th and no z's in the numerator. Then I have that over 36. The x to the negative 2nd is moving down, but his sign will change on his exponent there. I have a y to the 9th, and then I have a z to the 6th, and he's joined by a z to the 3rd. So, hold on one second, ladies and gentlemen. Okay, so now I'm ready to simplify further. And let me see, 2436. If I divide them both by 12, I think I'm going to get 2/3. All right, x to the 5th over x squared. There's going to be an x cubed in the numerator. I've got y to the 8th over y to the 9th. There's going to be a y in my denominator. The z's, z to the 6th times a z to the 3rd, will be a z to the 9th in my denominator. And there you go. All right, it's that simple. I don't think you need any more examples. Of course, you can feel free to rewatch that, especially if you're watching it on Thursday or Friday, and we're not doing this lesson until Monday in class. All right, that's it for the lesson. Mr. Lawrence signing off. Have a good night, everybody.